So this is a video for your review quiz that we'll be giving tomorrow in class on Monday. So what we gave is this handout. If you don't have this handout, you can just grab any sheet of graph paper or line paper. You can download some graph paper from online. So number 2 is giving us a table. And whenever you're given a table, the first thing that you want to do is put down where your X and where your Y is. So we're going to start by doing that. And when the table is not side by side like this one, it's from top to bottom, it's still the same rules that apply. So X always goes first. So I'll just go ahead and put an X there, and then I'll go ahead and put the Y at the bottom. That's the first thing we want you guys to do, to label your axes on the table so that you don't make any mistakes on the graph. So on the graph, X is always the one at the bottom and Y is always the one at the top. And we need to graph this data as it states in the question. Okay, so we're going to need to graph this by using the proper graphing success criteria. So we need a title here. In this case, it's 2 people growing a seedling, so we can maybe call it growth of a seedling. So there's a nice title. We need to label our axes. So my x-axis is actually the time axis. So I'm going to go ahead and put time down here. My units for time is in days. And then we'll go ahead and label the y-axis, which is the height. And the height is in millimeters. Okay. I'm trying to see if we're missing anything else. There's already arrows on our graph. We need to make sure that we scale this properly. So for the time axis, it actually goes from 1 to 9. So I would say you could scale this by 1s, but I'm going to actually scale this by 0.5. So don't forget to put the 0 on your axis. And because I'm scaling this by 0.5, this little line here is 0.5, and this little line right here is 1. So 1.5, then 2, 2.5, and 3. So just make sure that you're scaling this properly. And for me, every little line represents 0.5. So the line between 0 and 1 is 0.5, and I need to continue that all through my x-axis. Now I'm going to go ahead and scale my height. It needs to go from 4 to 45. Now, I'm not going to use a break in the graph because my data starts at 4, and I need to go all the way up to 45. So a good way to scale this, I would say, I'm probably going to go by 2.5s and see if that works. So 2.5, 5, 10. So I'm just going to continue with this and see if I'm actually... And I think this is going to be okay because it actually goes up to 45, which is perfect. You can scale it really however you want. It looks like I'm scaling by 5s for my height axis, but I'm not. It looks like it because it looks like 5, 10, 50. But if you look, there's a little line in between. So this actually means I'm scaling by 2.5. So I just have to put the data in at this point. So we start with x equals 1. And then the y value for that. So if the time is 1, I have to go to 1. And then I go up to a height of 4, which is approximately right here. So I'll just go ahead and put the data in, and then I'll be back. All right, so here's the data that I ended up drawing. Okay, this is pretty much almost a perfectly straight line, but let's see what they want us to do here. So we've graphed the data, and we need to describe the trends. So for question A, we need to describe the trends. I'm going to go ahead and type that in on the side. When you describe a trend, you don't want to just say that it's positive. You also don't want to say that it's just increasing. So what we want are some keywords here. Very, very important to have some keywords. And we'll go ahead and write them in right here. So as the time increases, okay, so there's the keywords. The height, oh, that shouldn't have a capital. So as the time increases in days, the height also increases. And I know this because if I look at my graph, I can tell that my graph is in a positive trend. So you can write that stuff down. It is a positive trend, and it is increasing. But what we're really looking for is this top part right over here. This is what we're looking for when we ask you to describe a trend. So it's very important that you do write that in. And we need both axes in there, so both variables, time and height. And we also want the words increasing and or decreasing. But in this case, it's definitely increasing. So let's take a look at what question B is. Draw a line or curve of best fit and explain how you decided which to draw. So here, I see a kind of linear data. So I know that my data is making a relatively straight line. It's not making a perfectly straight line, but it is making a relatively straight line. There is a pattern here. It's increasing. So there is a relationship. And if there is a relationship, then that means that I'm able to put a line of best fit. So I'm going to go ahead and try to put my line of best fit going through most points. Okay, it doesn't go through all points, but it does go through most points. And I'm just going to redo that with a slightly thinner line. Okay. So when you're making your line of best fit, make sure that you're using a ruler. And again, that you go through most points. So this line will be approximately just like this. Okay, that's an acceptable line of best fit. So this line does not touch every single point. Okay, it's a straight line that goes through most points. And notice how I started my line on my x-axis. It looks like it's kind of starting at 0, but it doesn't have to start at 0. This data just happens to be a relationship that does start at 0. But a line of best fit is a line that goes through most points, and that's the only rule that you need to follow. So I decided to use the line of best fit, so we're just going to write that down. I'll put it on the side here. I don't have enough room to put it over on the other side. So I decided to use a line of best fit because the data forms a relatively straight line. Okay, so when it forms, and there's a relationship here, there is an increasing relationship. So when there is a relationship, you see some type of pattern, okay, that means that you can draw your line of best fit. Okay, for question C, how tall do you think the seedling was after 4 days? So the key word here is 4 days. And we're estimating, which means we need to go to the graph and use that line of best fit that we just drew. So at 4 days, that's the x-axis. I'm going to go to 4 and I'm going to show my work by using these little dotted lines. And I'm going to go right up to the line of best fit and then make some dotted lines over to the height axis. And in this case, at 4 days, I'd say it's about 20 millimeters. Okay, so we can just fill that in here. At 4 days, the height of the seedling is approximately or about, don't forget that word because your line of best fit might look different than mine. So at 4 days, the height of the seedling is about 20 millimeters. So it's important to use complete sentences here. Extremely, extremely important to use complete sentences and not just to write a number. The word about, approximately, or around is also very important here because, again, like I said, your lines of best fit might be a little bit different. Okay? So if we go over to the next question, it's asking us how tall might the seedling be after 10 days? So we have to go to 10 days this time, and it's asking us how do we know? Well, if I come to my graph, I went up to 10 days. If you didn't do that, then you just have to follow the pattern for your scaling. And because I'm going up by 0.5s, I can keep going here. I don't just have to stop at 10. I can actually keep going 10.5, 11, 11.5, and I have room to go up to 12. So you need to continue your scaling, your X scale, if you don't have enough room. So I go to 10 days. And again, I have to show my work. If you guys don't show your work, we'll be taking some marks off. Okay. And then we're going to go right up to the line of best fit and head on over to where it touches the height axis. Okay. And in this case, I'm going to continue my y-axis here. So this is 45. 50 would be my top value. And because I'm scaling this by 2.5s, I'd say this is about 48 millimeters. So all you would have to do is continue and go to question 2 and say at 10 days. So at 10 days, the height of the seedling is around, I'll use a different word, is around 48 millimeters. So again, I'm using keywords. I'm using a complete sentence. And because I'm estimating, I have the word about or around. I've shown my work on my graph. This shows that I know where it came from. So it asks me also to explain how I know. So I used the line of best fit to estimate. That's how I know. Otherwise, you can't just take a random guess. And we don't want you guys using the table. If it says to estimate and you already made a graph and a line of best fit, we'd like you to use the line of best fit. It's a bit more specific that way. Okay, so the next question is asking about how many days might it take for the seedling to reach a height of 60 millimeters. So now you have to recognize that they give us the height. So I'm going to go to the graph and I'm going to go to a height of 60 millimeters, which is kind of a problem for my graph because mine only goes up to 50. So I'm just going to kind of extend my graph a little bit more. I'd say 55 is about here. And 60 is probably about here. So that's going to be a problem for me, but it's not really a huge problem. Just continue your little lines like I showed you. Okay, just make it as best as you can. You can extend your line of best fit as much as you can. Okay, and then use your dotted lines to come back down. So you're just extending everything. You're extending the height axis. You're going to have to extend your x-axis, which is your time axis. But here I would say that it's approximately 13 days. So we're just going to go right here and answer that question. So I estimate that it would take approximately, we said about 13 days for the height of the seedling to be 60 millimeters. Okay, I'm just going to double check that it was 60. Yeah, it was 60 millimeters. And there's the word approximately, which is right over here. And approximately 13 days again is acceptable. Again, your answer might vary, but as long as it's close to that answer and you're showing your work on your graph. Can you predict how tall the seedling might be after 1 year? So this one here, on the graph, it would be very hard to predict after 1 year because 1 year would be 360 days. So on the graph, you would have to extend quite a bit. And I think that would be very, very difficult. Also, the growth of a seedling, normally the seedling stops growing and becomes an actual plant. So it's hard to say the rate of the plant based on the information that we're given. I don't think we're given enough information here to determine what the height would be after 1 year. You also don't know how the grower is treating the plant. So are they a good gardener? Are they watering the plant? It could die, several factors here. So as long as you explain a little bit of something, then we'll be happy with that. So I would say that it would be very hard to predict after 1 year based on the graph and based on the table that we're given.